So for indirect addressing mode, okay, so a register is used as a pointer to point the data memory location. Okay, so in this indirect addressing mode, 3-pointer register will be used, okay, which is pointer register X, Y, and Z. Okay, since the what we call the address of each of the memory location is a 16-bit, so that's why pointer register X, Y, and Z should be 16-bit wide. Okay, so this pointer register X, Y, and Z is actually a combination of two registers, general purpose register. Okay, for X is a combination of R26 and R27. Y, a combination of R28 and R29, and Z is a combination of R30 and R31. Okay, so the for pointer register X, since it is 16-bit, okay, so since this is a 16-bit size, okay, wide, so you can divide it to 2 bytes. Okay, one is a low byte, the second one is a higher byte. Okay, for the low byte, okay, this is for coming from R26, while for the higher byte, this is coming from R27. Okay, so recall back, 1 byte is equal to 8 bits. Okay, so since your pointer register is a 16-bit size, so you have 2 bytes. So from these 2 bytes, you can divide it into low byte and high byte. Okay, meanwhile, for pointer register Y, it is a combination of R28 and R29, in which R28 is for your Y low and R29 is for Y high. And similar to the Z, it is also 16-bit size. Okay, so you can divide it into 2 bytes. One is a low. Low is coming from R30, while R31 is for the high byte. Okay, so this is the pointer register that you need to know in order to do the indirect addressing mode. Okay, so this is what I explained earlier. Okay, so the R26, R27, R28, 29, R30, and R31 of GPRs can be referred to as X low, X high, Y low, Y high, Z low, and Z high respectively. Okay, because the size of this pointer register is 60 bits, so you can divide it into 2 bytes. One is for the lower byte, and the other one is for the higher byte. Okay, let's look at this example. Okay, following instruction reads the value of the location pointed to by pointer register X. So this is the what we call here the instruction. Okay, on how you're going to do a indirect addressing mode, means that you're going to load a value from a location that are pointed to by pointer register. Okay, in this case here, it is a pointer register X, and you're going to put that value to R24. Okay, so to do that, okay, you can use the LDR24, X. So what happened here? Okay, so how the indirect addressing mode works? Okay, so we have a data memory, divided this data memory to three sections. Okay, on the top here, this is a GPR followed by IO and RAM. So for example, you have a LDR24X. So how this indirect addressing mode works? Okay, so first, what you're going to do is you need to look at the X. Okay, what is the X value? Okay, so you're going to find out what is the address that are pointed by pointer register X. Okay, since you know that the X is actually a combination of R26 and R27. So X is actually a combination of R26 and R27. So what you're going to do is you need to go to R26 and R27, which is located in somewhere inside the GPR. So this is your R26 and this is R27. Okay, you go to this GPR here and you need to find out what are the content, okay, or what are the value inside of this register. Okay, so this is the first step lah. Okay, you go to your pointer register X, okay, and then see what are the content inside of your R26 and R27. Okay, let's say lah, okay, the value inside of this R26 is and R27 is something like, okay, so this one is 40 and this is 01. For example, okay, we take as an example, okay, 0140. So what you're going to do is, okay, you just write down this is 0140 because R26 you have a 40 there, while R27 you have a content of 01. So you just write down the content of this registers here, and then so now you know that, okay, now you can make it as a memory address location, okay, which is you know that the X now point to address 0140. So what happened here? You go to address 0140, which is somewhere around your RAM. Okay, and then you take the value. Okay, okay, you go to the address pointed by X, which is the X now pointed to 1040. Okay, you go to that addresses, okay, to that memory location, take the value and put it to your R24. So this is how the indirect addressing mode works. Okay, so compared to direct addressing mode, the direct addressing mode, you already know the memory location, but indirect addressing mode, you doesn't know the memory location. So what you need to do is you need to go to your pointer register, see the content inside of your pointer register, so that you know that, okay, this pointer register pointed to this memory location. You go to that location, take the value and put to your GPR. Okay, so let's look at another examples here. Okay, so you're going to load the content, okay, of location 130 into R18. Okay, so I look at my data memory. Okay, so this is my R18. And this is address okay 0130. Okay, so what I'm going to do here is, okay, based on this example here, I'm going to take this value from address 130 and put it to R18. Okay, so you have two solutions here. One by using the direct addressing mode, the second one using the indirect addressing mode. Okay, let's see how we're going to do the first solution here, which is using a direct addressing mode. Okay, so by using a direct addressing mode, okay, what you're going to do is, okay, what instruction that you're going to do? Use by using a direct addressing mode to load this value from address 130 and put it to R18. Okay, can you tell me what instruction that we can use here? Anyone? Siapa nak tolong? Okay, we have
LDI,
okay,
Doctor.
LDI. You cannot use LDI because the value the value that you're going to load to R18 already inside of your memory. You cannot use the LDI. LDI only if you're going to load the value, a constant value or the immediate value from outside of your data memory.
LDS?
Yes, we use the LDS. Okay, for the direct address remote, you can use the LDS. Okay, what is the destination? R18. What about the address that you're going to load the data from? Address 130. So you just write down 0x130. Okay, so you go to address 130, take the value and put it to R18. This is by using the direct addressing mode lah. Okay, if you're going to use the indirect addressing mode, okay, so what you're going to do is, okay, first, you know the syntax for indirect addressing mode is, okay, to load the value from this, by using the indirect address mode, the syntax is LD, okay, what is the location, destination, R18, and what are your pointer register that you're going to use? For example, we're going to use a pointer register 1. Okay, so what happened here, if you use this instruction, okay, the CPU will go to see what are the content inside of your pointer register Y, which is, you know that the pointer register Y is actually a combination of R28 and R29. Okay, so CPU go to R28 and R29 inside of GPR and look the value inside here. Okay, but since in this R28 and R29 doesn't have any content or doesn't have any value. Okay, so what you're going to do? Because in this example, okay, you're going to load the content from location 130 and put it to R18. So you need to make sure that the Y is pointed to address 0130. Okay, so how you going to make your Y pointed to this address? Macam mana nak buat? How to do that? What are you going to do? Okay, how are you going to make this pointer register Y point to this address 0130? Because now the value inside of Y is 0, nothing. So how are you going to make this Y pointed to this address 0130? What are you going to do? Okay, so you're going to put this value to your pointer register Y. How? Okay, since this is a 16-bit, okay, you can divide it into 2 bytes. One is low and one is higher byte. Okay, so we already know that the low byte is belong to R28. So you put 30 to low and 01 to R29. Okay, so how are you going to do put this value to R28 and R29? By using the LDI instruction. Okay, so that's why LDI R28 with what value? 30, and LDI R29 with what value? 01. Okay, after you executed these 2 lines here, what happened? Your Y pointed to address 0130. Okay, then after that you can execute this line here, load R18 Y, means that first now you go to your Y, okay, your pointer register Y, since the pointer register Y already have value 0, 0130. Okay, so what happened here? So you go to address 0130, takes the value and put it to R18. Okay, so the difference between direct addressing mode and indirect addressing mode, you see that, okay, for the direct addressing mode, you only need to have one instruction line. But for indirect addressing mode, you need to have 3 instruction lines in order to do the same function or the same process. Okay? Okay, similar to this one. Okay, this is by using the what we call here. Okay, this example using the pointer register X. Okay, so what you're going to do is sama lah. Okay, so first you need to load this value 0130 to your pointer register X. Okay, so this is your X. 30. How to load this value to pointer register X? Okay, you need to divide it into 2 byte. One is become to low byte and this is become high byte. Okay, so low byte will go to your R26 and this is R27. Or if you don't want to use the R26 and R27, you can replace it by using the register name, which is XL and XH. Okay, you see here, load I XL 0 at 30. Okay, you put the number 30 to R26. Load I XH with OX01. So you put 1 to your X high, which is your R27. And then after that, load R18 with X. Okay, so you go to address that are pointed by pointer register X, which is 0130. Get the value inside this address and put it to your R18. Okay, so this is how the indirect addressing mode works in order to load a data from that in order to load a data from RAM or from memory address to GPR, you can use the LD instruction. Okay, what about if you're going to store the value, okay, from GPR to your RAM? What instruction that you're going to use? Okay, for this one, we can use the ST instruction. Okay, so the ST instruction can be used to write a value to a location to which any of the X, Y, and Z register points to. Okay, for example, okay, you're going to store the content of R23 into location 139F. So how to do that? By using first direct addressing mode and next indirect addressing mode. Okay, how to do that? Okay, first, using direct addressing mode. How to do that? Okay, you're going to store, okay, the value from address 139F to R23. Anyone? For the direct addressing mode, what instruction that you're going to use to store the value content inside of this memory address to R23?
LDS.
Okay. Is it LDS or STS? We're going to store.
SDS.
Oh, sorry. This one is incorrect. Okay. So supposed to be, okay, value from R23. Okay, you're going to put to this address. Okay, I'm sorry. Not from this address to R23. Okay, suppose R23, you have the value from R23. Okay, and then you're going to store it to location 139F. So what instruction that you're going to use? Minta maaf ya.
STS, Doctor.
Okay, STS. Okay, since you're going to store value from R23 to this location, so you're using the STS instruction for direct addressee mode. Okay, what are the destination? Okay, this memory address, which is OX139F. What are the source register?
R23.
23. Okay, so this is when you use the direct addressing mode. What about the second method, indirect addressing mode? How to do that? Okay, to do that, we can use the ST instruction. Okay, you use the ST and followed by, okay, your pointer register, we use the pointer register X and R23. Okay, so now what happened here? Okay, you go to R23, take the value and put it to the location that are pointed by pointer register X. But, okay, but what happened here is the value in pointer register X is 0. So now, how you going to make sure that the pointer register X pointed to this memory, this location? How to do that? Okay, because currently the X value here, the pointer register X value is 0.
We load
Okay,
immediate value to pointer register.
Yeah, correct. Okay, you're going to load this and memory location to your pointer register X. So since this one here, okay, you can see here, this is 16-bit data. Okay, you can divide it into 2 byte. One is low byte, the second one is higher byte. Okay, so 9F, you need to put here. This is a 9F, which is your R26. And 13 go to R27. Okay, so now you just write down LDI R26 with OX9F and LDI R27 with OX13. Okay, so now you know that, okay, the pointer register point to this address 139F. Okay, so this is how you're going to store the data from R23 to address 139F by using indirect addressing mode. Any question up until here? Ada soalan?
All clear, Doctor.
Okay, great. Okay, so now we look at what are the advantage of using register indirect addressing mode. Okay, because why? Okay, because just now, when we do the comparison, okay, the direct addressing mode is using a less instruction compared to indirect addressing mode. But why we need to use the indirect addressing mode? Okay, so now we're going to see the advantage of using indirect addressing mode. Okay, so the advantage using indirect addressing mode is that it makes accessing data dynamic rather than static. Okay, so let's look at these examples here, these few examples. Okay, so now then you can see more clear the advantage of using indirect addressing mode. Okay, now you're going to write a program, okay, to copy value 55 to the RAM location started from 140 to 144. So you have value 55, you're going to store to address starting from 140 until 144. So how to do that? Okay, so you have 3 options here, 3 solutions. One, by using direct addressing mode. B, register indirect addressing mode but without a loop. And C, register indirect addressing mode but with a loop. Okay, so let's look at the first solution here. Okay, you're going to use a direct addressing mode. Okay, so now, since this is a value, which is a constant number or immediate value, Okay, you're going to store it to this address 140 until 144. So what you're going to do, the first thing that you're going to do here is you need to load this value to your GPR. Okay, so that's why we use the LDI R17OX55. So what happened? After you execute this line, so R17 will have value 55. Okay, then next, after that, you can send this value to these addresses. Okay, starting from 140 by using STS instruction, because this is a direct addressing mode. Yeah? So you will using the STS instruction. Okay. What is the destination? The first destination registered, the first destination address that you're going to store? 0x140. Okay. Value from what register? Okay, you're going to send out 55. This 55 already inside R17, so you put R17. So what happened here? 55 will be stored to address 140. Okay, then you copy the same instruction because you're going to store it to address 140 next. 141. So 141 R17. Okay, and then you do it until STS OX144 R17. Okay, so this is direct address mode. Okay, next. Next solution is indirect addressing mode, but without a loop. Okay, the same thing. Okay, you're going to copy these numbers to address 140 until 144. So how are you going to do that? Okay, so this is a B solution. Indirect, but without loops. Okay, again, 55. Okay, so 55, you need to load it to your GPR. Okay, because this is a constant number, so you need to load it to your GPR. So LDI R17 OX55. So this is the first step. And then what are you going to do next after that? Okay, because you're going to use the indirect addressing mode, so you need to choose what pointer register that you're going to use. Okay, so in this example here, you are going to use the pointer register Z. Okay, so this is your pointer register Z. It's a combination of R30 and R31. So how are you going to make sure that this pointer register Z is pointed to the first address here, 140. Macam mana nak buat? How to make sure that the pointer register X pointed to the starting address 140, because you're going to store the data 55 to this address 140. Okay, so you're going to load. Okay, so since this is a 16-bit, okay, you can divide it into two lah. Okay, one is for the lower byte and this is for high byte. So this is a 40 and this is 0, 1. Okay, then what you're going to do is you need to load this value to R31 and 40 to R30. So LDI R30 with OX40. Okay, you can use the ZL instead of R30 and load I R31 OX01. So what happened after you execute this line here? Z now point to address 0140. Okay, next, what you're going to do? Then after that, we're going to store lah by using the ST instruction. Okay, you store this value to the first location. Okay, so ST R, sorry, ZR17. Okay, so what happened after you execute this line here? Okay, Z now point to address 0140. So at this location here, you will store 55, which is coming from R17. Okay, next we are going to store the card to the next address, which is 141. So how to do that? How to make sure that the what we call it, the Z now point to address 141, because currently, okay, the Z pointed to this address 0140. So how to make sure that the Z now pointed to new address, which is 141?
Increment, Doctor.
Okay, you need to increment. Which register that you need to increment? Is it R30 or R31?
R30.
Okay, we need to increment R30. So you need to increment by 1 to your R30. So that your Z is point to new address, which is 0141. So that's why we put the INC instruction here, increment ZL, or you can put the increment R30. So what happened? ZL or R30 now will have new value, which is 41. And then you store again lah. Okay, store ZR70. So what happened? Z now pointed to a new address, which is 141. And you store 55. Okay, and then next, you're going to store to the next address, which is 142. So you need to increment again lah, your R30. So that your ZL point to new value, which is 42, and Z pointed to new address 142. Okay, you keep repeating these lines here until, okay, your Z pointed to 144. Okay, and then when your Z pointed to 144, so what happened here? You store that value ZR70. Okay, so Z is 144, store number 55. Okay, so this is without a loops. Okay, so now C, okay, indirect addressee mode, but with a loops. Okay, how to do that? Okay, similar lah. Okay, same with this indirect addressee mode without a loop. First, you load 55 to your R70. Okay, because 55 is a immediate data, a constant number, so you need to load to your general purpose register first. Okay, then the second line here, okay, similar to this one here, you need to make sure that your pointer register point to the starting address 140. Okay, so LDI. Okay, so I just use the ZL OX40 LDI ZH0X01. So what happened here? Z pointed to address 0140. I will make it smaller. Can you see it? Boleh nampak tak?
Yes, Doctor.
Okay,
Yes,
next.
Doctor, yes.
What you're going to do? Okay, you're going to load another register. So this register here become your counter. Okay, because it's going to use a loop. Okay, so you need to have one register as a counter register. Okay, how many counter that you need to do this looping? How many loopings that you require in order to store from 140 to 144?
5.
Okay, how to calculate? How you get the value 5? Okay, we can have the formula. The formula is, okay, the end address, okay, which is 144, minus with the start address plus with 1. Okay, so end address, okay, counter equal to end address plus with start, sorry, minus with start address and plus with 1. So 144 minus 140, which is you get 4 plus with 1, you get 5. Okay, so the counter value should be 5. Okay, so that's why load I R25. So this is your counter. Okay, because we're going to do 5 looping. Okay, so that's why you put 5 there. Okay, next we store lah. Okay, we are going to store the value from R17 to the location that are pointed by pointer register Z. So now, initially, okay, your pointer register Z is pointed to what address? 140. Okay, so you're going to store 55 to this address. Okay, next, what you're going to do? Okay, you need to increment so that your pointer register Z point to new address, which is 141. Okay, how to do that? Similar. Okay, we increment our ZL. Okay, so now ZL become 41. Okay, since we are going to use a loops, okay, so we decrement our loops value, our counter, okay, which is R20. Decrement R20, and by using the BRNE. Okay, later in the module 5 or module 6, you will learn about these things here. Okay, how to mix a loop. Okay, so BRNE stands for if R20 not equal 0, it will keep looping. If R20 equal to 0, then it will stop looping. Okay, so BRNE, so you put the ulang. Or, okay, so this is the label that you're going to jump. Okay, so now R20, since our starting value of R20 is 5, your decrement by 1, so R20 become 5. Okay, brand not equal ulang. So when, where I was going to put this label here, this ulang label here. Kat mana nak letak? So I need to put here lah, dekat at this ST instruction. Why? Because after I increment my ZL, okay, then I'm going to store again the value, the 55 to the new pointer register, to the new address that are pointed by pointer register Z. Okay, so what happened here? So now, Z now point to new address, which is 141. Okay, increment ZL, ZL become 42. So sorry, yeah, this one become 4. Decrement R20, R20 now become 3. R20 still not equal to 0, so you keep repeating, store again the value. Okay, so now Z pointed to 142, store this value to 142, increment ZL, ZL become 43, decrement R20, R20 become 2. Since R20 is not equal to 0, so it will keep repeating, and now you store at address 143 with 55. Okay, so this one become 44, and this become 1. And when ulang, okay, since this still have value, so you need to store again. Okay, so now pointer register Z pointed to 144. Okay, you store that value to address 144. Increment ZL, ZL become 45, and you decrement R20, R20 0. Then when the R20 0, then you exit this loop. Okay, you do the next instruction, which is the instruction after BR and E. Okay, so this is what happens when you go, you do you store the 55 by using indirect addressing mode with a loops. Okay, so let's say lah. Okay, so previously we're going to store starting from this value starting from address 140 to 144. So let's say you're going to store the same value now from 140 until 155, for example. So how to do that? Okay, if you're going to use the direct addressee mode, okay, so what you're going to do? Okay, first you need to find out lah. Okay, how many what is the how many instruction that you're going to copy paste in order to store from 140 to 155. Can you calculate what are the counter that you're going to put here, starting from 155 minus with 140 plus with 1? This is in hexadecimal. The value is hexadecimal. So how many times? Okay, 155 minus with 140 plus with 1. Okay, so you get 16. Okay, convert to decimal, then you have 22. Okay, so 22. Okay, if you use the direct addressing mode, so what happened here is you need to copy paste this line here, STS 140 22 times. Okay, so you need to copy paste this line STS, okay, the addresses are 17 22 times. Okay, similar with this one here, without a loop. Okay, so you need to copy paste the same instruction. Okay, this instruction here 20 times as well. But if you use the indirect addressing mode, but with a loop, what are you going to do? Do you need to copy paste this instruction 22 times? No need.
No, no need.
Okay. So you only need to change at the counter register. Instead of 5, now you replace
22.
with 22. Okay, so that's why this is the advantage by using the indirect addressing mode. Okay, compared to direct addressing mode. Okay, so any question up until here? So now you can understand why the indirect addressing mode is more dynamic rather than static compared to direct addressing mode. Any question? Okay, if no question, okay, and then we look at the next slides. Okay, so in the previous example, okay, you need to use increment YL to increase the pointer because there is no such increment Y. Okay, we need to increment the lower byte in order to increase the pointer register value. Okay, so and looping is not possible in direct addressing mode as opposed to in direct addressing mode. So for the direct addressing mode, you cannot use loops. Okay, so loops only can be used for indirect addressing mode. Okay, next we are going to go to auto increment and auto decrement option for pointer register. Okay, so because the pointer register S, Y, and Z are 60-bit register, they can go from 000 to FFFF. Okay, so for the Atmega 32, of course the address can be from 000 until 085F only. Okay, but by using the increment ZL or increment YL or increment XL as a previous example, to increment the pointer can cause a problem when an address such as F, for example, 5FF is incremented due to increment YL, ZL will not propagate the carry into ZH register. Okay, for example. Okay, so we use the same example. Okay, previously, okay, we're going to send this value 55 starting from address 140 until 144. Okay, but now you're going to do the same thing, but okay, the end address that you're going to store here, not 144, but 205, for example. Okay, so by using the increment YL, so what happened here? Okay, so you started with 140 and then you increment your ZL, so and then it will keep increase until 1FF. Okay, so when 1FF, okay, suppose the next address that pointed by pointer register Z here is 200. Okay, since we using the increment ZL, so what happened here? Okay, so suppose the next address is this address, but by using the increment ZL, so what happened? Okay, you just increment this side here. Okay, so you have a 1FF. Okay, increment the YZL. So what happened? FF tambah plus with 1, you get 0, 0. And then you have a carry. But this carry not propagate to your ZH. Okay, so what happened? Now your Z pointed to address 100, not 200. So this is the what we call here the problem arise. Okay, when we increment the lower our pointer register by using the ZL, SL, or YL. Okay, because when you add FF with 1 and this value will not propagate, okay, the carry from this addition will not propagate to your ZH or YH or XH. Okay, so to overcome this problem, okay, so what you're going to do is we need to use the auto increment and auto decrement. Okay, so what is auto increment and auto decrement? So this is let's look at the auto increment addressing mode. So auto increment, which is we call it as a post increment, is available with pointer register X, Y, or Z register. So you see LDRD X plus. So X plus here means that it is a auto increment. Okay, and then you see this is the second instruction STZ plus RR. So means that this is auto increment. Okay, previously, okay, so this one here, so this is the one that we've done earlier. Okay, you see here STZ R70 and then you increment ZL. Okay, so in order to use the auto increment, so what you're going to do here is you just replace these two lines of instruction with STZ plus R70. Okay, no need to put the increment ZL after that. Okay, so this line is enough to increase your pointer register Z. Okay. Okay, so this auto increment typically used in looping structure to sequentially access memory by increasing address. So what happened here? Your pointer register is set for the first byte, and then you access repeatedly using a post increment to point to the next byte after each access, and then after that your y will be incremented. Okay, later we will see what this auto increment and auto decrement do. Okay, so for the auto decrement, okay, so this one here also typically used in a looping structure to sequentially access memory by decreasing the addresses. Okay, so what happened here? Set y to minus y address of the last first byte, access repeatedly using the pre-decrement to point to the byte access. So this is the syntax. Okay, so this is the summary of auto decrement and auto increment. Okay, so this is the instruction for the auto increment and auto decrement. Okay, by using the indirect addressing mode. Okay, if you see here, this is for pointer register X. Okay, you have to load a data from memory address to GPR by using the indirect addressing mode. You have 3 instructions here. Okay, the first line here is LDRNZ. So what happened after you execute this line here? Okay, so after loading a location pointed to by X, the X stay the same. Means that if you not put any symbol at the back of your X or in front of your X, means that once you load the value from from memory address that pointed by pointer register X, the X value remains. Okay, no change. Okay, for this one here, if you see the LDRN X plus. So what happened after loading location pointed to by X, the X is incremented. Okay, means that. Okay, I just put something like this lah. Okay, so that you can see it clearly. Okay, so let your X point to address. Okay, so this is the first instruction, LDR30X. Okay, so what happened after you execute this line here? Okay, you go to address pointed by pointer register X, which is 0140, get the value, put it to R30. Okay, so R13 equal to value from address 140. Okay, so whatever value lah inside of this address 140. What about your X? Okay, so the X remains. Okay, which is pointed to address 140. Okay, for the second line here, okay, second instruction LDR13X plus. So what happened here? Okay, first go to the address that are pointed by X, which is address 140, takes the value and put it to R13. So R13 will have the value that are pointed by X, which is address 140. What about the X? Okay, after you execute this line, X now will increase by 1, which is pointed to new address 141. Okay, because of this increment symbol. Okay, what about the third instruction? LDR13 minus X. Okay, you see here. So the X is decremented. Okay, you decremented the address that are pointed by pointer register X. Then the location pointed to by X is loaded. Okay, so since now, okay, X is pointed to this address 0140 because this is a pre-decrement, means that you need to decrement the address that are pointed by X. Okay, so what happened here? X pointed to address 13F. Okay, and then you go to this address. Okay, so R and put it to R30. Okay, so R30 will have the address, the data from address 13F. Okay, so this is what happened lah. Okay, you need to for the LDRNX minus X. Okay, so this is a post decrement, means that you need to decrease the address of the pointer register. Then after that, go to that address and put it to your register. Okay, and for Y and Z, okay, for the pointer register Y and Z, okay, the third here is similar only at this instruction here. Okay, it have another instruction called LDD. So LDD is stand for load with a displacement. Okay, this is only valid for pointer register Y and Z. Okay, let's lah. Y is also pointed to address 0140. So let's this one here. The fourth line is LDD R13 Y plus 3, for example. Okay, so if you look at this description here, okay, after loading location pointed to by Y plus Q, the Y stay the same. Okay, means that the Y no change to your pointer register Y. For example here, okay, LDD R13 Y plus 3. Okay, so X now, sorry. Okay, so R13 will have value from address 140 plus with 3, which is 143. So you take the value from address 143 and put it to R13. So what happened to your Y after you execute this line? Your Y remains, which is point to address 140. Okay, Y tak berubah after you do this replacement. Okay, so let's look at this what we call here, these examples here. Okay, you are going to write a program to clear 60 memory locations starting at data memory address 60. Okay, use the following increment Rn and auto increment. Okay, so now what you're going to do is you're going to clear, okay, put 0, okay, to the memory address started from R60 until 6F, okay, which is you have a total of 60 memory location. Okay, so starting from R60 until 6F. So what you're going to do? Okay, A by using the INCRN and B by using the auto increment. So since this one here, we're going to use a loop. Okay, so what we're going to do is we need to use the indirect addressee mode. Okay, so first, we just, okay, since you're going to put 0 to this address, so first you need to put this value to your register. So let's this one here we put, okay, so we put value 0 to register R17. Okay, so LDI R17 with 0. Okay, the first value put to R17, and we're going to use use the pointer register. So let's the pointer register that you're going to use here is X. Okay, so you need to make sure that this X is pointed to the starting address here, which is 60. Okay, how to do that? Okay, you need to load lah the value 0060 to your pointer register X. Okay, so load I R26 with OX60 and load I R27 with 0. So what happened here? X pointed to address 0060. And then you're going to do a loops. So how many loops that you require here? 16. Okay, because you're going to store the same. Okay, you're going to clear or you're going to store this value 0 to 16 locations starting from address 60. Okay, so that's why LDIR2016. Okay, so this is your counter. Okay, next. You put the ST lah, ST X R17. Okay, and then by using the increment RN, so you need to increment your, okay, so this is SL and this is your SH, so you need to increment your SL. Okay, and then decrement R20 and branch not equal, okay, repeat. So this repeat here, label repeat you put here. Okay, so this will be done 16 times. Okay, starting from address 60 until 6F. Okay, so this is for A lah. Okay, then B, the same example, but by using the auto increment. So to do the auto increment, okay, similar lah to what you did for the by using the increment RN, in which you need to clear your R17. Okay, make sure that your pointer register pointed to this address 0060 by using these two lines here, and then load your counter register. Okay, and then you store that value 0 to your pointer register X. Okay, so the difference here is, okay, instead of we use these two line here. Okay, now we can make it simple by writing STX plus R17 only. Okay. Okay, so you can simplify. Instead of using the two instruction, now you can use one instruction STX plus R17 and then followed by decrement R20 and branch not equal. Okay, so only to the different only this line here. Okay, you see this line and this line. Okay, the rest is similar. Okay, so this is a register indirect with displacement. I already told you how the displacement works. Okay. So now we are going to see the examples. Okay. Okay, so this is the general format for register indirect with displacement. Okay. So you have to load data by using a displacement. You need to have this one here, LDD RDZ plus Q. Okay, in where Q is the number between 0 to 65, while RD is your GPR from R30 to R0 to R31. Okay, for example, here you're going to read from a location that is 5 bytes after the location to which Z pointed to. So what you're going to do is you just simply write LDD R20 Z plus 5. Okay, so what happened here? Okay, you go to location that Z plus 5, take the value and put it to R20. What about your Z? The Z is remain. Okay, the value of your Z is remain. Okay, and then to store a byte of data, you can use the STD instruction. Okay, if you're going to store data by using the displacement, so you can use the STD instruction. So this is the instruction STD Z plus QRR. Okay, in which Q is the displacement that you're going to store to and RR is the value that you're going to store to that location. Okay, for example here, the following instruction write the content of R20 into the location that is 5 bytes away from the Z pointed to. Okay, so you just use the STD Z plus R20. So what happens here, you go to the value, you take the value from R20, store it to the location that are Z plus 5. Okay, what about your Z pointer register? The Z pointer register will remain. Okay, so let's look at these examples here. Okay, this is taken from what we call here, taken from test, if not mistaken. Okay, so you're going to do analysis. Okay, you're going to determine the result of 4 register and memory address by filling in all the empty boxes as provided after the execution of the following instruction. So these instructions are executed sequentially. Okay, what is the meaning of executed sequentially? Okay, it means that, okay, after you, for example lah, okay, you execute the first line, okay, then you're going to execute the second line. So whatever result that you get from the second, from the first line, okay, you need to use it in the second line. Okay, that is the execute sequentially. Means that everything that result from the previous instruction you need to use for the next instruction. Okay, given that the initial value of the register and memory addresses before instruction execution are given below. So this is the register value. Okay, the initial register value, and this is the initial memory value. Okay, so how to do that? How to solve this thing here? Okay, so let's look lines by lines. Okay, we have 4 instructions here. Okay, and then you see the marks here is 8 marks. Okay, so at the end of this, what we call here, okay, at the end of this question here, you are required to fill in the box, which is, this is the box that you need to fill out. Okay, the first box here is your registers. Okay, R20, R21, R22, R23, R30, and R31. And then the second box here is your memory addresses. Okay, so this is a 312, 313, 314, 315, 316, and 317. Okay. So now let's look at the first line here, LDR20Z. Okay, what this first line do? Okay, can you tell me what this first line do?
The value in Z register.
Okay, load. Okay, LDR20Z means that you're going to load the value that are pointed by Z register to R20. Okay, the question is, what are the locations that are pointed to by Z pointer register? Okay, what are the values that pointed to by?
6C.
Okay, so before that, okay, so first you need to know what are the Z pointer register. Okay, so the Z pointer register is actually a combination of R30 and
R31.
31. Okay, thank you, Azari. So R30 and R31. So according to this table here, okay, so R30 and R31, okay, has a value 0314. So you know that this is a 0314. Okay, so you know that, okay, now Z is pointed to address 0314. So you go to address 0314. So this is the address of 0314. Okay, get the value, which is 6C, and then you're going to load to R20. So R20 will have what value? 6C. Okay, so you just simply write down R20 now will have 6C. Okay, so no longer 0, 0. Okay, initial value of R20 is 0, 0. So now it becomes 6C. What about your Z pointer? Is it your Z pointer is changed or remains pointed to address 314? What about your Z pointer? Is it your Z pointer is increment by 1 or decrement by 1 or it remains? No change. After you execute the first line, the first instruction here, LDR20Z, what happened to your Z?
No change.
Okay, your Z is no change. Means that your Z still pointing to address 0314. Okay, so we finished the first line here. Okay, next, ST minus ZR21. Okay, so this is, okay, ST minus ZR21. So what this instruction do? Okay, so you know that, okay, we're going to take the value from R21 and store it to the location pointed by pointer register Z. Okay, so what is R21? Okay, so you go to R21. So this is your R21. Okay, we have the AC. Now you're going to take this AC and store it to location that are pointed to by pointer register Z. Okay, the question is, what is the address that are pointed by pointer register Z?
Three one three.
Okay, 313. Why 313? Okay, you see here? Minus Z means that it's a post decrement. Okay, you need to decrease the address of the Z, the current address of your Z. Okay, the current address of the Z is 314. You decrease by 1, so it becomes 0313. Okay, so you go to address 0313 and store the value of R21. Okay, so go to address 313. So this is address 313. So now the 313 will have new value, which is A, C. Okay, and then make sure that the jawapan here, okay, the answer here must be in hexadecimal. Okay, all the answer must be in hexadecimal. Okay, so I just put here, this is AC. Okay, so we finish the second line here. Okay, next. The third instruction, LDR22Z plus. Okay, third instruction is LDR22Z plus. So what this instruction do? Anyone? Siapa nak tolong?
Increment Z by 1.
Increment by 1, Doctor.
Okay, so since this is a post increment, means that, okay, so we need to get the what is the initial value, the current value of your Z. The current value of your Z is pointed to address 313. Is it? After the second instruction, the Z is pointed to 313. Okay, so what you're going to do is here is you go to address 313. Okay, which is this is address 313. You take the value and put it to R22. Okay, so this is R22. So R20 now will have a new value, AC. And then after that, what happened? The Z will increase by
1.
1. So now Z new is 314. Okay, so you need to clearly identify lah. Okay, is it a post increment or pre-decrement? Okay, so This one is pre-decrement. Okay, means that you need to minus your pointer register Z, and then after that you store it. But this one you need to load the value from your pointer register Z. Then after that you increment your Z by 1. Okay, so this is a Z. Z now pointed to the new address, which is 314. Okay, so R22, now we have a new value, which is AC. Okay, so make sure that the answer is in hexadecimal lah. Okay, and then we finish the third line. What about the fourth instruction here? STD Z plus 2 R23. Okay, so what does STD do? Okay, what the STD do? Okay, means that you're going to store with a displacement. Okay, store the value from R23, okay, to the address that are pointed by Z plus 2. Okay, the question is what is the address of the displacement here? Okay, you go to R23, which is BC. Okay, you're going to take this value BC and store it to what address?
314.
314 is a current address. So now what happens is you need to plus with 2 because this is a displacement.
Yeah,
okay.
316.
Okay,
316.
so you go to address 316 and store the value from R23, which is BC. Okay, so go to 316. This is your 316. Store the value BC. What about your Z? Is your Z change after that?
Z
No.
remain the same.
Okay, the Z remains. Okay, in which the Z is point to address 314, not 316, yeah, because this is a displacement. Displacement
Yes.
means that the Z remains, no change to your Z. Okay, although you store the value to address 316, but the Z is remain. Okay, so now we put the 316 with berapa ni? BC. Okay, and then what about your Z? Okay, you know that your Z is 314, so you just put your Z 314. Okay, so this is a 0314. What about the rest of the registered and memory address?
Still the same. Remain the
Okay.
same.
Okay, so you just copy back the value.
Yes.
Okay, so this is a AC. Okay, don't leave it blank. Okay, you need to copy back the value. Okay, if you leave it blank, then you will losing marks. Okay, so BCD is 5E, 6C, 7A, and 34. Okay, so this is how you're going to do analysis. Okay, you are given the register value and the memory address value, and then given a certain program, then you need to do analysis, find out what happened after you execute each of these instruction. Okay, so let's look at another examples here. Okay, we cannot see this one clearly. Okay, I just copy back the value. Okay, let me. Okay, I just put it here. Okay, can you see this one? Boleh nampak tak? Okay, can you see this exercise here? Okay, I give you around 10 to 15 minutes, okay, to try this exercise. And after that, we do discussion to get the answers.
4.
Okay, so Y is actually a combination of R28 and R29. Okay, and then you see here R26 and R27. This is your pointer register X. Okay, but for this instruction here, okay, it's telling you to get the address that are pointed by Y. So you go to this R28 and R29, which is 0414. So you know that okay, we need to take to load a value from address 0414 and put it to R23. So you go to address 414. This is address 414. Take the value 7A and put it to R23. So now it becomes 7A. Right? So,
Yeah, correct.
And then, okay, the third instruction here, ORI R25240. So what are you going to do here? Okay, so we can refer to our instruction sets. Okay, I will give you the instruction set later. I forgot to give you earlier. Okay, so this is the instruction set. Okay, and then you need to find out the ORI instruction. So this is ORI instruction. Okay, I make it bigger so that you can see it clearly. So this ORI telling you that you are going to do a logical OR with immediate value. So this is the syntax ORI RDK, in which RD is your destination register while K is your immediate value. So this is the what we call here the operation. Okay, RD do logical OR with K and put the result to RD. So we go back. Where is the page just now? Oh. Okay, so I need to recreate again the page. Sorry for that. Okay. All right, so we are in. Okay, so I need to redo again. Okay, so the first line here is R23. Okay, so this one is become 410 is become 00. Okay, and then the second one is LDR23Y. So you go to address 414, take the value and put it to R23. So now it becomes 7A. And now we are here, ORI R25. So I need to put a name here. If not, the page will gone. Okay, so ORI R25240. Okay, so R25, what is the R25? Is AC. Okay, so this is your R25. And now you're going to do logical OR with 240. Okay, so AC, in order to do a logical OR, so you're going to convert this value AC to binary numbers by using the 8421 methods. Okay, So it become 1010 for A, while for C is 12, actually 1100. Okay, what about 240? Okay, you can press the calculator and you will get 11110000. Okay, you do the logical OR. Okay, so this is a 0, 0, 1, 1, 1, or with 0 you get 1, 1, or with 1 you get 1, 1, 0 you get 1, 1, 0 you get 1. So the answer will be FC. So what happened here, after you execute this line, R25 will have value FC. Okay, so you just change this one from AC to FC.
But doctor,
Yeah.
240, it is decimal value, or we need to convert to hexa or what?
Okay, so this one here, okay, 240, since in front of this number here doesn't have any symbol. Okay, so it belongs to decimal number. Okay, so this 240 is a decimal number. So now, because we're going to do the logical OR, so better we change this 240 to binary number.
Okay.
Okay, so that's why you will get 11110000 to represent 240.
Thank you, doctor.
Okay. Okay, next, line number 4. Okay, ST minus Y R24. Okay, so what this instruction do? Okay, so you're going to store value from R24. Okay, so this is the value from R24, which is consists of 18, and put it to the to the address pointed by pointer register 1. But bear in mind that this is a pre-decrement, means that you're going to decrease the address that are pointed by Y, and then after that you can store to that location. Okay, so currently your Y, okay, after we did this the second instruction here, the Y still pointed to address 0414. Okay, so what happened here after you execute this line? Y now pointed to new address, which is 413. And what happened? You go to this address 413 and put the result from put the value from R24, which is the value from R24 is 18. Okay, so 413 now become 18. Okay, up until here, all of you get the same answers?
Yes, doctor.
Okay, great. Okay, now we go to next instruction, ADD R24, R27. So what happened here? Okay, you're going to add R24 with R27 and put the result back to R24. What is your R24? 18 plus with R27, which is BC. Okay, you can press the calculator. And then the result here is D4. Okay, so this D4 will be stored to your R24. So now here become D4. Okay, and next, decrement YL. Okay, so since Y, the current Y now point to address 0413. Okay, if you decrement YL means that, okay, Y now pointed to new address, which is 12. Okay, because previously the Y is pointed to 413. You decrement YL, Y now point to new address, which is 0412. Okay, so YL equal to 12 for this line. Okay, no need to update the value of your YL because you have a few instructions that involve the Y. So that's why I just simply left my pointer register Y. Okay, after the last instruction, then I will update it. value accordingly. Okay, next, LDDR27Y plus 3. Okay, what happened here for this instruction? LDDR27Y plus 3. Okay, means that you're going to load from displacement, okay, load displacement from the address that are pointed by Y plus 3 and put it to R27. Okay, so the current address that are pointed by Y is 412. Okay, so 412, you plus with 3, okay, you will get 415. Okay, so you go to this address 415, take the value, which is 98, and put it to R27. So this one now become 98. Okay, next, what about your Y? Is your Y value change to 415 or the Y remain at 412?
412.
Okay, the Y
412.
remains at 412. Masih lagi tak berubah. Okay, it's no change here for your pointer register Y. Okay, so we done this part. And then after that, NEG R26. So what does NEG do? Okay, so
To complement. To complement.
Okay, second complement, two complements. Okay, the NEG stand for two complements. So you go to R26, there is FE. So R26 equal to FE. Okay, so you change this FE to what we call here binary number. So you will get 1111 1110. Okay, the quickest way to change from this number to second complement is, okay, from right to the left, okay, you find the first number one. Okay, so this is your first number one. Okay, from right to the left, you find the first number one, and you copy back the value. Okay, so these two here, you copy back the value. What about the others? Then you complement. Okay, so this one becomes 0 because it is 1. Complement becomes 0. This is 0, 0, 0, 0, 0. So the value of R26 now becomes 0, 2. So R26 now become 0, 2. Okay, so you can just change this one. So now become 0, 2. And the last instruction, ST. Okay, so suppose this one, this is incorrect, not plus Y. There is no such thing plus Y. It's supposed to be Y plus. Okay, please change this one here. Okay, instead of plus Y, now become Y plus. Okay, STY plus R26. So what happened here? What are you going to do? Okay, you're going to store value from R26, which is 02, and put it to the location that are pointed by pointer register Y. So what is the pointer register Y? Okay, previously our Y point to address 412. So you go to address 412 and you store value from R26, which is R26 is 02. Okay, so 02, 412 now become 02. And then what about your Y? Is it your Y 412 or increased by 1?
Increase by 1.
Okay, now your Y increased by 1, which is pointed to address 413. Okay, now then after that you can update all the values. Okay, so this one here, so this is become 13. This is still remain 04, and the rest you just simply copy back the value. Okay, then you get 12 mark. Okay, any question up until here? Ada soalan tak? Okay, if no question, I think we stop here. Okay, before that, I will
Doctor?
give you, yeah.
This binary calculation, is it correct? Because isn't it 11001110? Because from the I confirmed from the calculator also.
Which line is this? Which line is that?
Just for the for the or immediate value.
Or immediate value.
Yeah, the binary addition.
Okay, so now, what is the number for 240? Wait.
11111000.
Okay, let me check here. Okay, 11111000. Okay, correct. So this is the value. Okay, so 111000. And then AC. Okay, AC, actually A is your 10. Okay, 8 plus 2 is 10, so 1010. C is actually A, B, C, 12. So 8 plus 4 is 12, 1100. And then you do the logical OR. You still remember the truth table or logical OR?
No, doctor.
Okay, if
Okay.
00, what happened? If 00?
0.
0, 0, 1, 1. 1, 0, 1, 1, 1. So you just compare this value here with the truth table.
I just did the normal addition.
Okay,
Okay.
it's not a normal addition. Okay, you need to
Okay.
do a logical OR.
Okay, thanks.
Okay, so I think we finish here. Okay, we stop here. And then before we stop, I'm going to give you an individual assignment. Okay, I will give the assignment in the WhatsApp groups. Okay, I hope, I assume that all of you already joined the WhatsApp groups, correct? Okay, and so the submission date is by next week. Okay, so thank you guys and see you next week.
Okay.
Okay.
Doctor,
Yeah.
what are we going to submit?